10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Cotangent theta to an expression in terms of sine and cosine. Explain the procedure. In order to solve this equation, we must first derive the two trigonometric functions, which are secant and cotangent theta. If we will look in the reciprocal identities, the equivalent value of secant theta is cosine theta, and the equivalent value of cotangent theta is 1 over tangent theta. So if we combine these two terms, it will result to 1 over cosine tangent theta. And in ratio identities rather, the equivalent of cosine tangent theta is sine theta, which means this will result to 1 over sine theta. And finally, if we will look again in the reciprocal identities, its equivalent value is cosecant theta, and that's how you will get the answer in that question. How will you combine cosine theta over 1 plus sine theta plus 1 plus sine theta over cosine theta to form a single expression? Explain the procedure. The first procedure that must be done is the and cosine theta times cosine theta is cosine squared theta, and then 1 plus sine theta times 1 plus sine theta is equivalent to 1 plus sine theta squared. And then if we will multiply this, we will to signify a multiplication operation. And then, if we will get the trinomial product of this binomial squared, the resulting will be 1 plus 2 sine theta plus sine squared theta. How did I get these trinomial terms? By using the following method. First, 1 times 1 is 1. Out, 1 times sine theta is sine theta. In, sine theta times 1 is sine theta. And last, sine theta times sine theta is sine squared theta. And then if we combine these two, this will be equal to 2 sine theta. So if we will substitute the value here, this will be the expression. And if we will look in the ratio identities, sine squared theta plus cosine squared theta is equals to 1. And then 1 plus 1 is equals to 2. And then just copy the another function. And then if we are going to factor this 2 plus 2 sine theta, the resulting factored form is 2 parentheses 1 plus sine theta. And then just copy the denominator. And since these are the same, this will be cancelled. And the remaining terms is 2 over cosine theta. And then if we're going to separate the two terms, this will be like that. 2 times 1 over cosine theta. And if we will look in the reciprocal identities, 1 over cosine theta is equal to secant theta. So secant theta times 2 is equal to 2 secant theta. And that is the answer to that question.
Explain how to verify an identity. No single method works for all identities. However, following certain steps might help. To verify an identity, you must use and transform the more complicated side into the other using basic identities, or use the both side and transform it to a single expression. Example, cosine theta, tangent theta equals sine theta. Solution, use tangent theta equals sine theta over cosine theta. From cosine tangent theta, it will be cosine theta parentheses sine theta over cosine theta. We will cancel the cosine theta and it will be sine theta. Sine theta equals sine theta is correct.
Describe strategies that can be used to verify identities. Pick one side, usually the most complicated side, and work to make it look for opportunities to add or subtract fractional expressions using a common denominator or factor trigonometric expressions. Look for opportunities to use the fundamental trigonometric identities. Convert trigonometric expressions to ones whose terms contain sine or cosine and simplify.
Describe how you feel when you have successfully verified a difficult identity and happy face. So you can see here, there's a clue, happy face. And my answer is super, ultra mega happy. Because I'm really happy that I can answer a very difficult question. And that's the end. Happy face.
Find the exact value of sine 105. So first, look at the addition and subtraction formulas. There are two, which is the sine quantity a plus b and sine quantity a minus b. Then look for sum or difference of the given angle, which is 45, 30, and 60. So use the 45 and 60 because 45 plus 60 is equals to 105. Then use the formula sine a plus b equals sine a cos b plus cos a sine b. Then substitute sine quantity 45 plus 60 equals sine 45 cos 60 plus cos 45 sine 60. Then look for the value of sine 45. So use the SOHCAHTOA, which is opposite over hypotenuse. Then sine 45 is in here in this triangle. Then the opposite side of the 45 is 1 and the hypotenuse is square root of 2. So it became 1 over square root of 2. Then the cosine 60 will use the adjacent over hypotenuse based on the SOHCAHTOA. Then here we'll use this triangle. Then the adjacent of the 60 is 1 and the hypotenuse is 2. So it becomes 1/2 plus. Then cos 45 will be using this angle. Then use the adjacent over hypotenuse, which is 1 over square root of 2. Then the value of sine 60, opposite, which is the square root of 3, and the adjacent is 2. Yeah. 2. Then rationalize this. To rationalize this, times it to the square root of 2. Is square root of 2. Then it will become square root of 4, which is equivalent to 2. So there. Then times 2.5 plus rationalize also square root of 2 over 2 times square root of 3 over 2. Then combine square root of 2 times 1 square root of 2. 2 times 2, 4. Then plus square root of 2 times square root of 3 equals square root of 6. 2 times 2, 4. Then combine. Square root of 2 plus square root of 6 over 4. Then that's the answer. Only find the exact value of tangent 105 degrees. Explain the procedure. First, we must find two values that will result to 105 if you add them, which are 45 and 16. And if we will substitute the values of this 45 and 16 to the equation tangent A plus tangent B over 1 minus tangent A times tangent B is, the resulting will be tangent 45 plus tangent 60 over 1 minus tangent 45 times tangent 60. And how did I get this from the square root of 3? What is the tangent 45? Even without using calculator, you can easily solve the value of tangent 45 because by using SOHCAHTOA, which is tangent equals opposite over adjacent, and the opposite of this is 1, and the adjacent is 1. So tangent 45 is 1, and then tangent 60, opposite is negative, is square root of 3 rather, and then over adjacent, which is 1, which equals to positive square root of 3. And then just copy 1 minus what is tangent 45? 1. And then times tangent 16 is square root of 3. Then distribute this, then the denominator will now become 1 minus square root of 3. And then add this expression to its conjugate, which its conjugate is 1 plus square root of 3. And if we will use the fund method in here, the resulting product will be 4 plus 2 square root of 3. And then this, since they are conjugates, the result will be just negative 2. And then if we are going to separate the two terms, they will be 4 over negative 2 plus 2 square root of 3 over negative 2. 4 divided negative 2 equals negative 2. Then it will become negative because positive divided negative is negative, and then this will be cancelled to 1, which is constant, so we don't have to emphasize that number here anymore, and then just copy the rational number, and negative 2 minus square root of 3 is the final answer.